Hello, dear students. Today we will discuss Fourier series. First we discuss about the Fourier series and then solve some related problems. At first we discuss Fourier series. Fourier series is a trigonometric series associated with the function fx by means of Euler's formulas. Here equation 1 represents a Fourier series, which is fx is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx, which is equation 1. Here a naught, an and bn are given by Euler's formulas as equations 2, 3 and 4. Here a naught is 1 upon pi integral minus pi to pi fx dx, an is equal to 1 upon pi integral minus pi to pi fx cos nx dx, and bn is 1 upon pi integral minus pi to pi fx sin nx dx. If function fx is even function of x, that is fx is equal to f minus x, then equation 4, this equation gives, for even function fx, this equation gives 0, and therefore Fourier series reduces to Fourier cosine series. Fx is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx, which is equation 5. Equation 5 is known as Fourier cosine series. Similarly, if fx is odd function of x, that is fx is equal to minus f minus x, then equations 2 and 3 give a naught is 0 and an is 0, and then here an is 0, a naught is 0, then this Fourier series reduces to fx is equal to summation n is equal to 1 to infinity bn sin nx, like equation 6, and equation 6 is known as Fourier sine series. First problem, expand fx is equal to x for minus pi less than or equal to x less than or equal to pi in Fourier series, and hence sum the series. We have to find the sum of this series. Now fx is equal to x is odd function of x, because if you put here minus x, then f minus x will be minus x. It is odd function, and therefore a naught will be equal to an is equal to 0 in Euler's formulas, and the Fourier series will be Fourier sine series. Series given as fx is equal to summation n is equal to 1 to infinity bn sin nx. Suppose this is equation 1. Now bn is equal to 1 upon pi minus pi to pi fx sin nx dx. Here fx is x, therefore we get 1 upon pi minus pi to pi, fx is x, and this is sin nx dx. Here x is odd function, sin nx is also odd function, therefore odd into odd will be even function. That is, due to symmetry, you can replace this limit from 0 to pi by multiplying this by 2 here. So therefore bn will be equal to 2 upon pi integral 0 to pi x sin nx dx. 2 upon pi is common, and we can integrate this with the by parts method, taking x as u and this as v. So it gives x into integral of sin nx is minus cos nx by n from 0 to pi minus 0 to pi. Derivative of x is 1. Antiderivative of sin nx is minus cos nx upon n into dx. 2 upon pi, n can be taken common in both, into n. Here we get minus common. Upper limit pi into cos n pi, pi into cos n pi, minus lower limit 0 into x becomes 0, this much, and its integral is, n has been taken common, minus minus plus, cos n pi gives its integral as sin n pi by n from 0 to pi. Sin n pi is 0 and this is sin nx. Sin n pi is 0 for upper limit and sin 0 is 0 for lower limit. So this gives 0 for both limits, and we get this pi cancels this pi, we get minus 2 upon n cos n pi. Because cos n pi is minus 1 to power n, so you can write it as minus 1 to power n, because cos n pi is minus 1 to power n. When n is equal to 1, we get cos 1 pi, which is minus 1. When 1 is 2, we get cos 2 pi plus 1 and so on. Or when this minus goes here, it gives 2 upon n minus 1 to power n plus 1. N power plus 1 power. So this is the value of Bn. Putting this value of Bn in equation 1, we get, therefore equation 1 gives Fx, which may also be written as x will be summation n is equal to 1 to infinity. Bn is 2 upon n minus 1 to power n plus 1 into this sin nx, sin nx. Or it may be written as fx is equal to x is equal to 2 summation n is equal to 1 to infinity minus 1 to power n plus 1 sin nx. Therefore, fx will be equal to x is equal to 2 into, when n is equal to 1, 1 plus 1 will be minus 1 to power 2 positive. So first term will be sin x upon 1. Next term will be, for n is equal to 2, this is minus 1 to power 3, which is negative, sin 2x by 2. Next term will be, when n is equal to 3, this will be positive, plus sin 3x by 3. Next term will be similarly negative, sin 4 x by 4 and so on. This is the required expansion in Fourier series. Second part, putting x as pi by 2 equal to pi by 2 in above equation, we get this is pi by 2 is equal to 2 sine pi by 2 minus sine 2 into pi by 2 upon 2 plus sine 3 pi by 2 upon 3 minus sine 4 pi by 2 upon 4 and so on. Therefore, pi by 2 will be equal to 2 into sin pi by 2 is 1. This term is sin pi, which is 0. This sin 3 pi by 2 is minus 1. So next term will be minus 1 by 3. Again sin 4 pi by 2 means sin 2 pi will be 0. Next term will be sin 5 pi by 2 negative. So sin 5 pi by 2 means positive 1 upon 5 and so on. So this 2 comes here and we get the sum of given series as 1 minus 1 by 3 plus 1 by 5 minus and so on as pi by 4, which is the required result. Note, fx is equal to x gives sawtooth wave from minus pi to plus pi and beyond this as this graph fs. This is x 0 pi 2 pi minus 2 pi and so on. So like this. This is sawtooth wave.